So let's read this definition. This definition first says that we start with a matrix A. The first thing this requires is that this matrix is a matrix that has the same number of rows as the number of columns. So columns, it has as many rows as columns. It's a square matrix. So that's the first requirement the first thing required in this definition. And then it says consider a vector that is not a vector of zeros. So we're thinking of this being a column vector, and this says that we're going to consider this non-trivial vector, a vector that doesn't contain all zeros. Maybe some of the entries are zeros, but not all the entries. And this says, look, if the product of the matrix times that column vector, if this product, this is a vector in Cn, right? So here you're multiplying an n by n, multiplying that times an n by 1. So that is giving you already a column that is an n by 1 column. That's a vector in Cn. So if that multiplication ax is a scalar multiple of x, we would say that that vector is an eigenvector for some scalar lambda. This lambda is some scalar for which this equation is true. And here I want to emphasize that what we have on the left hand side is a square matrix multiplying a column vector, and what we have on the right hand side is a scalar multiplying a column vector. So this product on the left hand side is a column, and this product on the right hand side is also a column, right? So we would say that this is an equation, but it definitely is a vector equation, right? So it's not a matrix equation, it's not a scalar equation, instead is a vector equation. That means that there are two columns with n entries. There are two objects that are n by 1, and those two objects are of equal length, and they match each other. And so that would be the idea that this matrix vector product equals this scalar column vector product. Okay, and so that equality in words says, well, turns out that that product ax is a scalar multiple of the non-trivial vector x. So this is the definition of that such scalar. This says for some scalar. Well, that such scalar with this scalar here is what we would call eigenvalue. And the non-trivial vector for which this vector equation is true is going to be dubbed eigenvector. So in words, we would write the scalar lambda is called an eigenvalue of the matrix A, and x is an eigenvector corresponding to lambda, so that it will be an idea, a notion of having a vector for which this vector equation is true given a particular value lambda. And so if that is the case, we would say that vector, that eigenvector, corresponds to that scalar that is called an eigenvalue. So in a way, it's like they come as a group of two, as a team. And however, that team has one scalar and one vector, and the scalar is called, maybe it should be called eigenscalar, but it's called eigenvalue, and that vector that is specific to that eigenvalue is called eigenvector.